Starship Flight 13 is fully stacked right now on the pad. SpaceX confirms 2 Raptor engines were swapped, but eagle-eyed fans count more than 10. A storm is rolling in from the Gulf. One weather system could ground this rocket before it even lifts off. Liftoff is targeted for Thursday, 5:45 p.m. Central. Will the sky cooperate, or does Flight 13 get scrubbed again? Stick around, this story is moving fast. At Starbase, Texas, Booster 20 and Ship 40 are sitting on top of each other again, fully assembled. This is the second time these two vehicles have been paired, and that detail alone matters. Something went wrong before, forcing SpaceX to pull the rocket apart, rebuild it, and stack it all over again. That's not a small operation. It takes a 469-foot-tall robotic tower called Mechazilla, precise timing, and a crew watching every millimeter of alignment. So why the second attempt? Go back to July 16th, the date of what appears to have been an aborted launch. The rocket rolled straight back to the production site. Engineers pulled the booster apart, inspected it, and began what SpaceX called an engine replacement campaign. Not a repair, not a patch, a replacement. That word matters. Replacing something means removing it entirely and starting fresh. And that's exactly what happened to at least some of Booster 20's 33 Raptor engines. The story gets more interesting from here. The engine mystery. Elon Musk said 2 engines were swapped, a clean number, the kind that suggests a minor fix, nothing dramatic. But when the booster rolled back to the pad on the evening of the 21st, people who track every bolt on these vehicles noticed the engine nozzles didn't match. Different wear patterns, different colors, different manufacturing marks. If only 2 engines changed, 31 others should look untouched. That's not what observers saw. Some estimates put the real number above 10. That's a 5 times gap between what was said publicly and what the hardware seems to show. So, which is true? 2 competing theories, and neither one is boring. 1. Only 2 engines had a genuine problem, and the rest were pulled simply for easier access during inspection, then reinstalled. That would explain the mismatch without anything actually being wrong with them. 2. SpaceX found a deeper issue, something systemic, and swapped far more hardware than it first admitted while keeping the public message simple. SpaceX hasn't clarified which one it is, but whatever happened, the company judged it serious enough to delay the entire flight and rebuild the booster before trying again. That's not how you treat a minor issue. After all that engine work, you'd expect a full static fire. Load the propellant, ignite the engines, while the booster stays clamped to the ground. Verify every Raptor fires correctly. That didn't happen. On July 22nd, SpaceX loaded propellant into Booster 20. Frost patterns showed the liquid oxygen tank fully loaded, while the methane tank was only partially filled. Loading continued for about 30 minutes. Then nothing. No ignition. You just replaced possibly 10 or more engines, and the very next test skips the one procedure built to prove those engines work. Why? The likely answer is something called a spin prime test. Propellant flows all the way to the engines, spinning the turbopumps, but nothing ignites. It checks the plumbing and fuel delivery without burning a drop of propellant or risking engine damage. A rehearsal without the fireworks. There's a simpler explanation too. Replacement Raptors go through acceptance testing at the factory before they ever reach Starbase. Each engine is proven individually before installation. If SpaceX trusts that process, a full static fire becomes less necessary. Just a cryogenic proof test to rule out leaks, and the job is done. SpaceX backed this up with a short public statement. Additional pre-flight testing on Super Heavy complete. Not successful static fire, just testing complete. That phrasing is deliberate, and it signals confidence rather than certainty from a company that has lost more than one Starship on the pad before. The storm on the horizon. With the booster cleared, Ship 40 made the 2-hour trip to the pad on the afternoon of the 22nd. Mechazilla lifted it into place and stacked it on top of Booster 20. Full stack, second time, 24 hours from launch. SpaceX then posted something specific. Preparations underway to launch as soon as tomorrow, Thursday, July 23rd. Target time, 5:45 p.m. Central. Notice the phrase "as soon as," not a promise. A target. And there's a reason for that hedge. A storm system is moving in from the Gulf of Mexico. Forecasts suggest the storm's core won't pass directly over Starbase. That's the good news. But a storm doesn't need a direct hit to shut down a launch. Gusty winds can push a vehicle off course during ascent. Rain interferes with sensitive electronics. Low clouds and fog block the ground, tracking systems responsible for confirming the rocket's exact position in flight. For comparison, commercial pilots fly through storms constantly, but they operate with decades of data and enormous safety margins. A brand new experimental rocket carrying volatile propellant has none of that cushion. Every weather variable becomes a potential abort trigger. So, it's a standoff. A fully assembled rocket, tested and ready, against a weather system with no regard for launch schedules. SpaceX itself is calling this a significant watch item, in the company's own words. That tells you they're genuinely unsure how Thursday plays out. Most coverage of Flight 13 misses something entirely. While every camera pointed at Starbase, SpaceX quietly launched a mission that could reshape how satellites are treated for decades. On July 21st, a Falcon 9 lifted off from Cape Canaveral carrying MRV-M1. Nobody noticed, because Starship stole every headline. But long-term, this mission might matter just as much. Right now, when a satellite in geostationary orbit runs low on fuel, it's essentially dead. Not broken, not damaged, just out of gas. And since it sits nearly 36,000 kilometers above Earth, there's no gas station up there. So companies scrap a satellite worth hundreds of millions of dollars and launch a brand new one instead. That's like abandoning a car over an empty tank, then buying a whole new car instead of refueling it. MRV-M1 is built to fix exactly that. The mission carries a robotic vehicle with 2 mechanical arms, each about 3 meters long, developed through DARPA and the U.S. Naval Research Laboratory. Alongside it ride 3 propulsion pods called MEPs. The robotic vehicle grabs each pod and physically attaches it to an aging satellite that's still functional but nearly out of fuel. That pod becomes the satellite's new engine, adding up to 8 more years of service. Think of it as a jump start, except the jumper cable is a robotic arm reaching across empty space to dock with hardware that was never designed to be touched again. The robotic vehicle doesn't retire after delivering all 3 pods either. It stays in orbit on standby, ready to service more spacecraft. According to Northrop Grumman, it can inspect satellites, relocate them, perform repairs, and even refuel itself through a passive interface the U.S. Space Force has already approved as the first standardized orbital refueling system. Standardized is the key word. Any future satellite built to that interface could be serviced the same way, not a one-time fix. Infrastructure. Which raises the real question. If satellites can be repaired and refueled in orbit instead of replaced, what happens to a business model built on launching new ones every few years? MRV-M1 just fired the opening shot on that debate. The hidden race. While SpaceX juggled a giant rocket and a satellite servicing mission in the same week, a smaller competitor made its own move. On July 21st, Relativity Space signed an agreement with Space Florida to build new manufacturing and testing facilities near Cape Canaveral, backed by up to $134 million in state funding. The target is Terran R, a reusable medium-lift rocket that hasn't flown yet, but is already competing for serious contracts. Relativity secured a spot in the U.S. Space Force's National Security Space Launch Program, meaning it can bid on government missions before the rocket has left the ground once. A bold bet, building government trust before the hardware proves itself. There's a practical reason behind the Florida move, too. Earlier this year, Relativity shipped a Terran R second stage from California to Mississippi by sea, through the Panama Canal, just to run tests. Weeks of transit for a single piece of hardware. Building production facilities directly in Florida solves that at the source. Space, Florida's president called Relativity exactly the kind of partner the state needs. A confident statement for a rocket that hasn't flown yet, but backed by a 9-figure investment. Confidence like that tends to mean something. Buried inside all this growth is a twist almost nobody discusses. A recent NASA Office of Inspector General report warned that Kennedy Space Center could hit full infrastructure capacity by 2029, not 2050. 4 years from now, SpaceX is stacking rockets on a weekly cadence. Relativity is building nearby. Other companies are expanding too, all competing for the same roads, the same power grid, the same limited land around Cape Canaveral. A SpaceX Florida vice president put it plainly. Before anyone can accomplish anything in orbit, the ground infrastructure has to be able to support it. It's easy to get excited about engines, storms, and robotic arms. Roads, power lines, and permits don't make for good headlines, but without them, none of the exciting parts happen at all. Worth sitting with. Is the next real obstacle to space exploration going to be rocket science? Or something as mundane as traffic and electrical capacity around a launch pad? All of it converges on one moment, Thursday, 5:45 p.m. Central. A booster with a disputed engine count. A test campaign that skipped its most obvious verification step. A storm that refuses to confirm its path. an industry expanding faster than the ground beneath it can support. Flight 13 isn't just another launch attempt. It's a pressure test for everything SpaceX has built to this point. The engines, the testing philosophy, the weather tolerance, and the infrastructure holding it all up. 2 engines or 10. A static fire skipped or simply unnecessary. A storm that misses or one that doesn't. Thursday answers every one of them at once. That's the full picture straight from the data. I'm Adrian. This is the Space Brief. If this breakdown helped, like, share, and subscribe. Drop your take below. More analysis is right on screen now.